Hi, how's it going? Welcome to Code with Z. Today's question is LeetCode number 33, search in rotated sorted array. Now I'll explain and visualize everything in the coming slides, but for the sake of reading the question, let's see what the question is actually asking us for. So as you can see, we're given an integer array called nums, and this is sorted in ascending order. Before they pass this array to our function, they're gonna make some modifications to it. Now you might ask, what kind of modifications are they gonna make to the array? Well, I'm glad you asked, because they're gonna rotate it. How are they going to do that? Well, they're going to pick an index called k, and then they're going to rotate the array from there. We can see that clearly in the example. As you can see, we have this array 0, 1, 2, 4, 5, 6, 7. As you can see, it's sorted in ascending order, and now they're going to rotate it. For example, they're going to rotate it at the third index. Well, let's see which number has the third index. 0, 1, 2, 3. So this number here has the third index. So they're going to rotate the array from this point. And as you can see, this array became this array. And now it's 4, 5, 6, 7, 0, 1, 2. So this is the array that they're going to pass to our function. And when they do that, they're also going to give us a target number. For example, here it's 0. And we got to return the index of this number inside of this rotated array. As you can see, 0 has the fourth index inside of this array. So we're going to return 4. And if we look for a number, for example, 3, that doesn't exist inside of our array, we're going to return -1. Now, for solving this problem, we can easily loop through each number inside of our array and return the index. But the problem is that's going to give us the time complexity of n. And the maximum time complexity that we can have is log n. And because of this, we can't just loop through all of these and find the index and return it. Alrighty, let's solve this together. And don't worry, I won't finish this video until I make sure you fully understand how to solve this problem. Making these slides took me ages, but I hope it provides you with value. Now, as you can see, this is our array of numbers after it was rotated, and this is our target number. We gotta return the index of this target number inside of our array if it exists, and if it doesn't exist, we're gonna return -1. Now, I'll explain the structure of the algorithm, and then I'll visualize the whole process, literally from the beginning to the end, so you can see how everything works. Now, if we think about it, we gotta find the index of this number here, right? So this is kind of a searching algorithm. And because it says log of n, and usually when we hear like log of n and searching, we should start thinking about binary search. But the problem with that is, if we use binary search here, it's gonna fail. Why? Because this array is not completely sorted. As you can see, some part of it is sorted, but the other part that was actually rotated is not sorted. So you can come to the conclusion that we should use binary search if we wanna have like some optimal time complexity, but we gotta make some modifications to it so we can actually cover this edge case here. In binary search, we usually have 3 important and simple variables. One is called left, that's going to be equal to the index of the first element inside of our array. And one is called right, that's going to be equal to the index of the last element inside of our array. And one is called mid, which is literally the index of the middle value inside of our array. And when we have these 3 numbers defined, finding the index of the target number is pretty easy, because we're going to check if our array was properly sorted. We're going to be like, all right, so this is sorted. So we know everything before this middle number here is going to be smaller than the middle number because it's sorted. And anything after this middle number is going to be greater than the middle number. So let's check if our target number is greater than our middle number. That means we have to check this part, and we can easily ignore this part because all of these numbers are smaller than our middle number. And if our target number is greater than our middle number, we know for sure that we don't need to check this part here. And vice versa, if our target number was smaller than our middle number, we can easily ignore these because we know these numbers are gonna be greater than our middle number. But now the issue is that our array is not sorted. So we're gonna have the structure of our binary search, and we're gonna make some modifications to it. So the first thing that we need is to define these 3 variables, right? So we're gonna define left. And as you can see, it's going to be equal to 0 because it was pointing to this number here. So the index of this number is going to be 0. Then we're going to have our right variable that's going to be equal to the index of the last element inside of our array. So nums.length -1, meaning the index of the last element inside of our array. And then because we have to go through these numbers, we obviously gonna need a loop. And this is gonna be representing our loop. And we're gonna keep on looping as long as left is smaller than or equal to right. Again, don't worry about anything. I'm just explaining the structure, and then I'll visualize everything so you can see how everything works. So after this, inside of our loop, we're gonna have our middle variable that's gonna be equal to left plus right divided by 2, and that's gonna give us the index of the middle number inside of our array. And then we're gonna check if the number that our middle variable is pointing to, for example the 7 here, is equal to our target. So we're gonna say if nums of mid is equal to the target, return mid, because when we find the target we have to return the index, so we're gonna return mid. And if our nums of mid was not equal to our target, we gotta find the sorted part of our array. So for example, if this is our current middle value, one side of this number is gonna be always sorted. Well, let's check. If we check the left side, 4, 5, 6, 7. Well, this sounds sorted to me. If we check the right side, this is gonna be 7, 0, 1, 2. As you can see, it's not sorted. When we find the side that's sorted, so for example, if the left side is sorted, we're gonna do a bunch of stuff. So first, we gotta find the sorted side. And then when we find it, we're gonna make some modifications based on that. We're gonna say, if target is between the nums of left, this is the number that our left variable is pointing to because in the beginning it's going to be equal to 0, and the middle number. So if the number that we currently look for, meaning our target number, lies between these two numbers, for example, because this is going to be the number that our middle variable is pointing to, and this is going to be the number that our left variable is pointing to. Again, I'll visualize everything. I'm currently just explaining the structure. If the number that we want is between these two numbers, right should be equal to middle minus 1. We're going to be like, ignore all of these and come to this side. And if that's not the case, meaning we can't find the number between these, we're going to be like, well, send left to the right side. So we're going to say left is equal to middle plus 1. So we're going to be like, left should be equal to this number, because we're going to be like, we've already checked middle number and we know that this part is sorted and the number doesn't lie between these. So we're just going to remove and ignore these and we're going to check this part. And else, meaning if the left side was not sorted, meaning if the right side was sorted, we're going to literally have the same thing. We're going to say, is target between the middle number and the right number? So is the target between this part? If it is, that means we can easily ignore the left side. So we're going to say left is going to be equal to middle plus 1. So left is going to be equal to this. And if that's not the case, meaning target is not between nums of mid and nums of right, that means it actually lies in the left side. So we're going to be like, right is going to be equal to middle minus 1. So we're going to bring right to this number here. So right is going to be pointing to this number. Now we're going to get to the visualization. But before that, I want you to know that the reason behind looking for the sorted side first is because we're going to update our right and left variables here. So we got to update these values based on the information we have on the sorted side. The only reason we can update the right and left values confidently is because we're going to look for the sorted side and we're going to check if the number is not between those two. For example, nums of left and nums of mid, or nums of mid and nums of right, we can update the right and left values. But if it was not sorted, we could never tell if the target number is between those two numbers. And if we don't find any answers, at the end, we're going to return minus 1. Now let's visualize everything together. So in the beginning, left is going to be initialized to 0. And 0 is going to be the index of this number here. So nums of 0 is going to be pointing to this number. And then right is going to be equal to the index of the last number, and that's going to be pointing to this number. So nums of right is going to be pointing to this number. So left is equal to 0, and nums.length minus 1, that's going to be 1, 2, 3, 4, 5, 6, 7. So the length is 7. Nums.length is 7 minus 1, that's going to be 6. So left is going to be equal to 0 and right is going to be equal to 6. Then we're going to enter our loop and we're going to calculate our mid, and we're going to say left plus right divided by 2. Well, left is 0, right is 6. 6 divided by 2 is going to be 3. So our mid variable is going to have the value of 3. Now, what does this 3 mean? Well, this 3 is the index of this number here. So as you can see, 0, 1, 2, 3. So nums of mid is going to be pointing to this number because 3 is the index of this number inside of our array. Then we're going to check if nums of mid, which is the 7 here, is equal to our target. Well, let's check our target. Target is 0. Is 7 equal to 0? Nope. So we're not going to get inside of this if statement. And then we're going to check if the left side is sorted. Well, let's check. This is the left side. Is it sorted? 4, 5, 6, 7. That sounds pretty sorted to me. So we're going to enter this if statement and we're going to check if the target number is between the nums left and nums mid. So is the number that we want, meaning this target number, in this area? We're not going to include mid in this part because we've already checked mid here. So is the number that we want inside of this area? Well, not really. So this statement is going to be false and we're not going to get inside of this if statement, and we're going to fall inside the else, and we're going to say left is going to be equal to mid plus 1. Mid is 3 plus 1, that's going to make left 4. And now nums of left is going to be pointing to this number here because this is the number with the index of 4. And then we're going to get to the end of our loop and we're going to repeat another round because we're going to keep on looping as long as left is smaller or equal to right. Currently left is 4 and right is 6, so this condition is true and we're gonna keep on looping. In this round, we're gonna calculate our mid again. We're gonna say 4 because the value of left is 4 plus 6. This is the value of right. That's gonna be 10 divided by 2. This is gonna be 5. So middle is gonna be equal to 5. Let's see what number has the index of 5. Would you look at that? It's this number. So nums of mid is gonna be equal to this number here. Is nums of mid, which is 1, equal to our target number, which is 0? Well, not really. 1 is not equal to 0. Then we're gonna check if the left side is sorted. So is the left side, meaning from left to mid, sorted? So is this part sorted? Well, yeah, 0, 1. This sounds sorted to me. And because of it, we're gonna get inside of this if statement and we're gonna say, is target between nums of left and nums of mid? And again, remember, we're not gonna include mid here because we've already checked it here. So we're gonna be like, including nums of left all the way to nums of mid, but we're not gonna include this. Is target between these numbers? Well, yeah, we only have one number, and yeah, we can easily say that 0 lies in this range. So we're gonna be like, all right then, so middle is 5 minus 1, that's gonna make right be equal to 4, and if right is equal to 4, it's gonna be pointing to this number, as you can see. Now left and right are both pointing to the same number, and we're gonna repeat our loop again, because left and right are both equal to 4, and this condition is still true. So we're gonna calculate our mid again. We're gonna be like 4 plus 4, that's 8 divided by 2, that's gonna be 4. So our mid is gonna be pointing to this number here. So is nums of mid, meaning 0, equal to 0? Well, yeah. Then let's return 4 because mid is 4 and we're gonna return the index. And this is our answer. Now let's code this in the simplest way possible. Alrighty, so first of all, we're gonna define our left variable just like we saw in the slides, and this is gonna be equal to 0. And then below this, we're gonna define our right variable, and this is gonna be equal to nums.length minus 1, again, just like we saw in the slides. And then below this, we're gonna have our loop, and we're gonna say while left is smaller or equal to right, keep on looping, and we're gonna enter our loop. Here we're gonna define our middle variable, so we're gonna say let mid be equal to left plus right, and these have to be inside of parentheses, so left plus right divided by 2. But for example, if our left value is 5 and our right value is 2, 5 plus 2 is gonna be 7. And 7 divided by 2 is gonna be equal to 3.5, and we basically don't have the index of 3.5. So we gotta get rid of this decimal here. And because of that, we're gonna say, let me go back, we're gonna say left plus right divided by 2, but math.floor has to wrap this, and this is basically gonna get rid of that decimal. And then below this, we're gonna check if our middle is pointing to the right number. So we're gonna say if nums of mid is equal to the target, return mid. And if this is not the case, we gotta check if the left side is sorted, right? So we're gonna say if nums of left, meaning the number that left is pointing to, is smaller or equal to the number that mid is pointing to, do the following. And this is basically checking if the left side is sorted. How? Well, if the array is sorted, the left side is always gonna be smaller or equal to the middle part. For example, if we have this array and this is the number that left is pointing to, which is 1, and this is the number that right is pointing to, which is 3, because it's sorted, left is always going to be smaller than middle, because 1 is always going to be smaller than 3. And this is how we check if the left side is sorted. So if the left side is sorted, we have to check if our target number is between left and right. So we're going to say if target is greater or equal to nums left and target is smaller than nums of mid. So if the target is between left and mid, do the following. We have to bring right to the left side because we know target is between left and middle. So we have to bring right from the other side to the correct side. So we're gonna say right should be equal to middle minus 1. And if this is not the case, meaning the target is not between left and middle, we're gonna be like, all right, so I guess we have to send left to the other side. So we're gonna be like else left is gonna be equal to middle plus 1. And if the left side was not sorted, we're gonna be like else, meaning the right side is sorted. So you have to check if the target is between middle and right. So we're gonna say if target is greater than nums of mid and target is smaller or equal to nums of right. So if target is between middle and right, we gotta bring left, right? So we're gonna say left is equal to middle plus 1. And if target is not between middle and right, we're gonna say else right is gonna be equal to middle minus 1. And then at the end, if we didn't find an answer, we're gonna say return minus 1. Now let me zoom out. This is gonna be all of our code. Now let's run it and see if we're gonna pass it. Moment of truth. Yep, as you can see, 1, 2, 3, all 3 are passed. Now let's submit it. Drum roll, please. I'm just kidding. Let's see if we're gonna pass it. Yep, that's awesome. Thanks for watching. Don't forget to like and subscribe and keep on coding.